So welcome everyone to the office. Like Scott said, I'm Jeff Reedy. I'm one of the other co-founders and the CEO. So as Scott mentioned, I'll give you a very brief. I don't want to bore everybody with company and marketing propaganda when you guys want to see the tech stuff. But since for some of you guys in the room, this is the first time you've seen us, I do want to kind of bring you up to speed and maybe catch you up. So the guys and I started Scale actually back in 2007. So we are approaching our 10-year anniversary. We started as a scale-out SAN NAS company, and so for the first 3 years of existence, that's what we sold. So we have a deep background in storage, but starting around mid-2011 and then launching our HC3 product in 2012, we made the transition into what we now call hyperconvergence. So we'll talk about that. Since that time, we've shipped thousands of clusters all over the world. We are the market leader in what we call non-VMware based hyperconvergence. So our virtualization is based off of KVM, but as you'll see in the demo here, most of our customers would never even touch KVM at all. But all of our customers are running on that platform. We've won lots of awards and other cool stuff, and I'm not going to bore you with that. But you will find that we are probably the most reviewed HCI product out there from a customer standpoint. Recognizing that perhaps because we're based in the Midwest, Midwestern guys, we don't have quite the same marketing engine that others in the HCI space have, but we do rely on our customers to do that. So you'll see lots of great reviews all over the place, almost 300 published case studies online at this stage. So I'm going to jump into the demo. This is going to be a very high-level demo just to give you guys a sense. But when we're talking hyperconvergence, what we mean is server, storage, and virtualization all in one. So some people like Howard in the room know this and others don't. But back in 2012, we actually coined the phrase hyperconvergence, and perhaps now with some irony, originally to differentiate ourselves from most of the other companies which are now lumped into hyperconvergence. But the key is that we were two big differences. One is that we always included the hypervisor, and that's what the word was supposed to mean, was converged infrastructure inclusive of the hypervisor. So I already mentioned KVM being in here. The other thing that's going to be very different about us, and you'll see in the demo, is that we do not use a VSA. So we have a software-defined storage stack that exists outside of the hypervisor. That's a lot of what Phil's going to dive into initially once I get through the demo. And then we'll get into some of the new stuff like NVMe, and then the brand new product that we're actually just announcing today, the HC3 Cloud Unity product. So as I dive in here, it's easy for you guys to put yourself in the into the shoes of your average IT professional. When we launched the product originally, we focused only on small IT shops. So the original product could only handle comfortably 10, 20 VMs. Today we do a lot more than that, and I'll go through some customer examples after the demo. But the whole idea behind the product is it was meant to be extraordinarily simple and easy to use, right? So really radically simplify the entire environment. Most of our customers, even today, even the large one, will commit all of their infrastructure over to Scale, and we basically become their entire environment. No more SAN, no more VMware, et cetera. So I am zoomed in here, but this is our UI, so I'm just remotely connected into one of our demo clusters. Now this is a 3-node configuration. One of the things that's interesting about Scale is that we scale both very small and very big. So we're going to show you, we have what we believe is the world's smallest HCI deployment, which is a single node. Phil's going to demo that. We also are in process of rolling out with, which will soon be our largest customer, where we are replacing about 30,000 HP servers with Scale. So we kind of run the gamut. In this case, this is just a basic 3-node cluster. Kind of across the top here, you can see it's 24 cores and 376 gig of RAM, et cetera, et cetera. That's not any one system, that's the environment as a whole. So as the customer needs more resources, they plug in more nodes. The nodes don't have to match what's already there, and everything joins together, and you're good to go. These squares, or something I call them post-it notes that you see, are the actual VMs. So what I'm going to do for you, again, to give you an idea of how the product works, we're going to deploy a VM. I'm going to set up replication and show you how the DR stuff works, talk a little bit about, very briefly about data tiering, and then we're going to cut it back over to Phil. So let's create a new VM, which I will call Tech Field Day. Put in a group called Jeff. Now, anything that will virtualize under KVM will work here. For most of our customers, of course, that means Windows and Linux. But we have some customers that are running, all sorts of different OSs. So I'll pick. Doesn't matter which one I pick. Windows 2012. Hit the Create button, and that's all it takes. So if I come down here and look for the Tech Field Day. This is the VM we just created. You can see it there. I'll power it on. Now what's going to happen is it's going to load balance across the cluster and determine where to actually spin this VM up. So we're going to see that happen in just a sec. And I don't know which one it will pick, but we'll see as soon as it comes up. Now, when this thing comes up, there it is. So it's actually running. I just highlighted it there on the first node in the cluster. You can see it there in blue. This is a RAM view of the environment, and if I hit the console button, you'll see it's the exciting world of installing Windows. Now, of course, most customers wouldn't start there, but they would start with a. There goes that thing. Oh, sorry. There we go. They would start with a gold master image and so on and so forth. So let's talk. Oh, now, I should mention, now from the instant that VM is created, it's already highly available, and Phil will go into this a little bit with Scribe. But at least in the most basic setup here, every block of data that exists for that VM, including the underlying data store, is mirrored in at least one other physical location within the cluster. That allows us to sustain an entire node failure and have everything keep running. So just to illustrate that, I recorded this earlier. This takes typically about 2 minutes, but I just do a hard chord pull on this third node in the cluster. So you see it goes down, and you're going to see alerts start to pop up here in the UI, but then you'll see the VMs that we're running there pop up on the other nodes in the cluster, right? So, for most of our customers, but certainly over half of our customers, these are small environments. These guys often don't even have redundant power supplies. We see, this is sort of real world stuff. I mean, we see power failures all the time, and so the system was architected from the very beginning to handle all kinds of hardware failures, whether it's, power and obviously drives and nodes, et cetera. Now, in most cases, we find that, the most common cause of power failure, somebody turned something off they weren't supposed to. So they just plug that back in, it'll automatically rejoin the cluster, and you're good to go. We also use that same kind of technique for doing upgrades to the system. So if there was an upgrade that required a reboot, not all upgrades do, but if it required a node reboot, the system would just live migrate the VMs off of that node, update it, move them back, and then move on to the next node. So again, for a small IT shop that doesn't want to come in at 2 in the morning on a Friday to do a system upgrade, this is a pretty key benefit for them. So let me come back here, show you how the replication works. It's built in. So when I click this, I get a little button that says Set up Replication. After I pick that, I just get a simple drop-down box of any other cluster which I've got access to. So in this case, I'm going to send this to our Indianapolis office cluster, like so, hit replicate, and that's all it takes. So now on whatever schedule I define, I'm using the default schedule here, but you can set this up however you like. It's going to take a snapshot, replicate that snapshot over the WAN to the remote site, and then continue to do that on the differentials over time. And you set that up on a per VM basis. All right, so extraordinarily easy to do. And if I come over here, which I know I've got to adjust the screen again, there we go. So I should find, yep, there's the, here's the VM. It's currently being replicated over the WAN to the Indy office. Now, if something happened in that environment, all I would do is come in and clone that out. So something like this. Here's a clone button. Hit this, and you'll see that pop up. Point your DNS over to it, and you're back up and running. Now, this is foreshadowing a little bit about some of the stuff that we're going to show you with Google later in the presentation. But this is kind of the base use case where I've got multiple offices, multiple scale environments, and I'm replicating data between those environments. One of the really cool things about the way the DR works is handling the fail back scenario. So if in fact I went offline, I failed over to that remote site, and now I want to come back. And of course, we find, other than hurricane season aside, most of the time when there's a DR scenario, it's just somebody lost power for a period of time. So you would come back in here and say, okay, let's send that back to the other office. It will then check the other office that's now back alive, find the snapshot that's closest to this data, and only send the differentials back over to catch it back up. So in other words, if you were offline for 2 hours, you only got 2 hours worth of data to send back, as opposed to kind of wiping everything out and starting over. So meant to be very, very simple. Last thing I'll talk about here in the demo is the data tiering. So in this particular case, I have a cluster here that's got a mix of SAS and SSD based flash. We do have systems, and we still sell systems that are all spinners. It's been one of the things that's been a little different about us than other HCI vendors. Our ability to use very low-end systems is really capitalizing on the efficiency of the Scribe architecture, which Phil will talk about. In this case, it's a hybrid. We also do all flash, but about 80-some% of the customers will end up with a hybrid environment. So what we do is we just track the block access, and Phil will go into Scribe. It is a block engine. So we're tracking how all the blocks are being accessed across the cluster, and simply put, we'll take the hot blocks and move those to the fastest tier of storage, and then move the cold blocks to the cheapest tier of storage, and that will happen in real time. So you can see here, if I just click this edit button on this virtual disk, a little slider bar that says flash priority. So what the slider bar is doing is it's basically setting the threshold at which time we determine a block to be hot. Most customers would never touch this. They're just going to let the algorithm figure it out, and it's good to go. But you can scroll this to the right and say, okay, I need this to go faster, have more access effectively to the flash. So you can set that from 1 to 10, and we're geeks, so we have things like absurd and hyperspeed and ludicrous speed in the product. But there's two special settings. One is what we call turn it to 11. Spinal Tap reference if you're keeping count. But turn it to 11 means all flash all the time, right? So transaction log for the database server, maybe you crank that up this way, and that's good to go. The other special setting, and probably even more important, is 0, which means go straight to the spinners. So this is a database front-ending big image files, PDF archive at a bank of check images. Storing part of a PDF on flash doesn't make any sense and sucks up all the flash. So send that thing down to 0. We also see a lot of customers use this for things like user desktop files where they're storing family photos and other stuff on their expensive infrastructure. You can crank that down to 0. And you can change this in real time. This is live and running, and I can move it around. So things like if I come in, a particular workload is running slow, you're a retailer, it's Black Friday, the point of sale system's running slow, I can actually live give that more access to the flash, perhaps at the expense of other applications, but I'm proactively making that call, right? And I can watch that happen and then move it back down. Same thing, we see customers do this if they run kind of non-ordinary big SQL queries or something like that are going to be slow. They'll crank it up temporarily, and that's good to go. So that's the product in a nutshell. I'm sure you've got questions, but we'll get to those here in a bit. All right, so this is just very quickly, I forgot, I was going to show you guys just the process of adding a node. So these are the screenshots. So in this case, same type of cluster that you see that I was demoing off of. I create some VMs, and now I'm getting alerts. And what the alerts are telling me here is that I don't have sufficient room to handle that node failover I was talking about. Right, so in this you can visually see I'm sucking up too much RAM here. If I lose a node, I can't catch all the VMs, right? So you'll get alerts in the UI. So what you do is you add another node to the cluster. It will join while this thing is live and running. You can see it pop up there. Stuff will move back over, and you just keep going. Right, and again, I know we passed out some price sheets, and Craig will talk about that in a bit. But one of the things to bear in mind with Scale is all these different products are interoperable. So if you find that you need a lot of archival storage to be added to your system, you could add a node, just add a whole bunch of fat spinning disks and add it to what you've already got, even if these are hybrid. Or at the other end of the spectrum, if you need to add all flash, you could add all flash and these sorts of things, right? So lots of flexibility, and we've got customers that started with us many years ago doing just all spinners, and obviously have continued to add to those clusters over time. So I'm going to talk about a couple of very quick customer case studies to give you an example of why people buy Scale. So the first one I'll talk about here is Farm Bureau Insurance. Obviously a very large enterprise type customer. and in fact, very different than the type of customer I talked about us serving, 5 years ago when we launched the product. This is their first entry into hyperconvergence. They had talked to many other vendors and ultimately settled on Scale specifically because they wanted to move away from VMware, which is not uncommon for our customers. They sent this really ugly slide when we asked them, why did they pick us? And the bottom line is they said, well, they estimate, and they've been a customer now for just over a year, but they estimated their 3-year cost savings to be about a little over 50% versus the VMware-based infrastructure. So we recently, and there's a case study that's going up now, asked them to update and how are we tracking to this performance. And this is what they said, we don't even know, but you've saved us millions, right? And the big difference is that, yeah, all these costs are true, right? The cost of buying Scale versus buying, servers and a SAN and VMware or what have you did save them a bunch of money. What they underestimated was how much time we would actually save them in terms of humans working on the environment. So you guys saw, you basically have been trained into the basics of administering this system. It is point and click easy. These guys have gone from multiple full-time people babysitting infrastructure to now they don't really have anyone full-time dedicated to it. So that's what's really changed the environment for them. Second one I'll talk about, let me back up, is this UnityPoint Health. So UnityPoint Health is the 9th or 10th largest healthcare network in the US. Have almost 300 clinics, about 18 university hospitals, and a whole bunch, 50 or 60 community hospitals. Now, the interesting thing about a healthcare environment is that when you look at the big university hospitals, they look like enterprise-type environments. They have IT staff, pretty sophisticated systems. As you go out into these community hospitals, that is not the case. They have much smaller staff. They look kind of like a classic mid-market company. When you go all the way down to a physician's office, they don't have any IT staff, right? And so, what they've been able to do with us is deploy one solution that fits all of those different environments. So at those university hospitals, they have large clusters, big environments, smaller clusters at the community type hospitals, and out those individual clinics and labs and things, they're running single node systems. Now you may ask, well, what happens in my power failure scenario in a single node system, and it's just off, right? there's no magic here. If you unplug one node, it's offline. However, you do get all the other benefits, and the DR is built in, and really that ease of use. They can remotely administer the thing. If they even had to walk someone through over the phone and how to spin something up or shut it down, they could do that. So this was a good fit for them. And we see the same kind of thing a lot in retail environments as well. We're out at the stores, they have VMs, they have applications that need to run, but often they're very light workloads, and we can scale down in that case to fit that. So just to wrap up here, one of the things, and this has honestly changed over the last 2 years since we saw some of you guys last, is that we do have lots and lots of large enterprise customers, and these are the kinds of things any company likes to talk about, like Farm Bureau and Lindt Chocolate and Steel Dynamics. I mean, last quarter I think we had 4 or 5 Fortune 500 companies that came online. But what we like to talk about, and is really kind of at the heart and soul of Scale, are our mid-market customers. So for every large enterprise we probably have 200 companies that you've never heard of, right? So I picked these somewhat intentionally. Big Al's Aquariums, which is an aquarium retailer in Canada. Rocco's Collision. Don't ask me why I have Big Al's and Rocco's on. It sounds like it's a mafia. Right? But in any case, these are real.
Well, some of us know, Joe.
Yeah. There you go. Right. So these guys hardly even have real logos, like Seaver County Bank and stuff, right? And so these are the environments that we built the product for. Small, understaffed, under-resourced IT departments. But what we found is that those now apply very well into larger environments. As well. So I just highlighted kind of the big 5, I guess, for us, verticals that we go into, which you can hardly call it a vertical when you've got 5 of them. But these are the ordinary business you drive past, thousands of every day, right? And, manufacturer with 200, 500, 1,000 employees making parts for GM or something, right? This is the kind of customer that we serve. So
does Carl Strauss fit into the healthcare portion of that, or?
Yeah, it's certainly in the stress relief portion. So I would argue, yes, that's definitely healthcare. Yeah. Somewhere between manufacturing and healthcare, right? Yeah. The other thing is, I'll just say, as a as one of the founders, and it is often a lot more fun to visit these kind of customers than the great big, the Fortune 500s. When you go see Carl Strauss, I mean, they hand you a beer as you walk in, right? So that's always pretty cool. So, all right. Any quick questions for me before I turn it over to Phil, and we're going to talk about the Scribe SDS architecture? No? All right. Thank you, Phil.
You knew I was coming, so you didn't put a school district, because there's always a school district.
That is the best NASCAR slide.
Yes. That's the best NASCAR slide I've seen in months.
Yeah.
I mean, the thing is, like I said, I mean, sometimes, and I have competitors say things about other competitors, and it's all fun and games in this stuff. But they'll, because we embrace these types of customers, they'll say, well, scale's not fit for the enterprise, right? Which I've shown you it is, but. Look, I mean, we're building the company to serve these kind of folks, and it's going well.